One AI agent can answer questions, but multi-agent systems can plan, divide work, collaborate, and solve complex tasks together. Let's begin with complex tasks need AI teamwork. One AI agent can answer questions or complete a small task. But many real problems are bigger than one simple response. They need research, planning, analysis, checking, and action. That is where multi-agent AI systems become useful. Instead of one agent doing everything, several agents work together. Each agent can focus on a specific role. Together, they can solve tasks that are too complex for a single assistant. That sets up what you will learn. To make this simple, we will build the idea step by step. First, we will define AI agents and multi-agent systems. Then we will compare single-agent and multi-agent workflows. Next, we will explore roles, communication, planning, and tools. After that, we will use business and study examples. Finally, we will cover risks, governance, and when to use this architecture. With what you will learn in mind, the next piece is what is an AI agent. Before we discuss teams of agents, we need one clear definition. An AI agent is a system that works toward a goal. It can understand a request, plan steps, use tools, and produce an output. Some agents only support simple tasks. More advanced agents can use external tools and remember workflow state. The key idea is agency. The system can decide the next useful step within boundaries. A multi-agent system builds on this idea by using more than one agent. That idea leads directly to what makes it multi-agent. A multi-agent system uses two or more agents in one workflow. Each agent may have a different role, skill, tool access, or responsibility. One agent may research. Another may analyze. Another may review the answer for quality. The system becomes powerful when agents coordinate instead of acting randomly. So multi-agent AI is not just many bots, it is organized collaboration. Once what makes it multi-agent is clear, single agent versus multi-agent becomes much easier to understand. The difference becomes clear when the task grows. A single agent handles the whole task by itself. That can work for simple questions or short workflows. A multi-agent system divides the task into smaller responsibilities. Specialized agents can work in sequence or in parallel. A reviewer agent can check the final output. This structure can improve clarity, depth, and reliability. From there, the next practical step is a simple team analogy. Think of a multi-agent system like a project team. A manager breaks the work into parts. A researcher gathers information. An analyst finds patterns. A writer prepares the output. A reviewer checks quality and risk. The same teamwork idea can be applied to AI agents. This sets up the next important point, core components of a multi-agent system. The team analogy leads to the main building blocks. A multi-agent system needs roles. It needs communication between agents. It needs orchestration to decide the order of work. It needs tools and data access. It may need memory to track progress. It also needs guardrails so agents do not act outside safe limits. That sets up role specialization. Role specialization is one of the biggest benefits of multi-agent design. Instead of one general agent trying to do everything, each agent has a clear job. A research agent focuses on information gathering. A math agent focuses on calculations. A critic agent checks mistakes and assumptions. A coordinator agent keeps the task moving. Clear roles reduce confusion and improve teamwork. With role specialization in mind, the next piece is orchestration, who coordinates the agents. Specialized agents still need coordination. That coordination is called orchestration. A supervisor agent may decide which agent should act next. A workflow graph may define the sequence of steps. Some systems use handoffs from one agent to another. Good orchestration prevents chaos. It turns individual agents into a structured workflow. That idea leads directly to communication and handoffs. Once orchestration exists, agents need a way to pass work forward. That is where communication and handoffs matter. One agent may send findings to another agent. Another agent may ask for missing information. A reviewer may return feedback to the writer. Clear handoffs reduce repeated work and misunderstanding. Poor communication can make multi-agent systems fail. Once communication and handoffs is clear, planning and task decomposition becomes much easier to understand. The next important idea is task decomposition. Complex work becomes easier when it is divided into smaller steps. A planning agent may break the task into research, analysis, execution, and review. Each step can be assigned to the right agent. This makes the workflow more transparent. It also helps humans inspect what happened. Good decomposition is one reason multi-agent systems can handle complex tasks. From there, the next practical step is tools and shared context. After a task is divided, agents often need tools and context. A research agent may search documents. A data agent may query a database. A coding agent may inspect a repository. A workflow agent may update a ticket. Shared context helps agents stay aligned. Without shared context, agents may produce disconnected results. This sets up the next important point: 3 collaboration patterns. Multi-agent systems can collaborate in different patterns. Sequential collaboration means agents work one after another. Parallel collaboration means agents work at the same time. Debate or review collaboration means agents challenge and improve each other's output. The best pattern depends on the task. A simple task may need one sequence. A complex decision may need parallel analysis and review. A complex decision may need parallel analysis and review. That sets up example, research report team. The first practical example is a research report. A planner agent creates the outline. A research agent finds reliable sources. An analyst agent extracts key findings. A writer agent drafts the report. A reviewer agent checks evidence and clarity. This creates a structured research workflow instead of one rushed answer. With example, research report team in mind, the next piece is example, customer support team. A customer support workflow needs speed and accuracy. One agent reads the customer message. Another checks order status. Another retrieves policy or troubleshooting steps. Another drafts a reply. A review agent checks tone and escalation risk. The final response can still go to a human before sending. That idea leads directly to example, software development team. Software work is a strong use case for multi-agent systems. A product agent reads the requirement. A coding agent suggests a change. A test agent writes test cases. A security agent checks risky patterns. A reviewer agent summarizes the pull request. Developers still approve and own the final code. Once example, software development team is clear, example, finance operations team becomes much easier to understand. Finance workflows often require evidence and controls. One agent checks invoice data. Another compares purchase order information. Another reads policy rules. Another calculates mismatches or risk. A reviewer agent prepares the recommendation. High-impact financial action should require human approval. From there, the next practical step is example, supply chain and logistics team. Supply chain work involves many moving parts. A demand agent analyzes forecast changes. A logistics agent checks route and shipment status. A supplier agent checks supplier risk. A planning agent compares options. A communication agent drafts updates for stakeholders. This helps teams respond faster when disruption happens. This sets up the next important point, example, student study team. Multi-agent systems are not only for companies. Students can also understand the idea through a study team. One agent explains a topic simply. Another creates practice questions. Another checks the student's answers. Another builds a revision plan. This turns AI from an answer machine into a learning workflow. That sets up benefits of multi-agent systems. Across these examples, the benefits become clear. Specialized agents can improve focus. Parallel agents can save time. Review agents can catch errors. Tool agents can connect workflows to real systems. Planner agents can make complex tasks easier to follow. The result is a more structured way to use AI for serious work. With benefits of multi-agent systems in mind, the next piece is risks and failure modes. The same structure that creates power also creates risk. One agent can pass a wrong assumption to another agent. Errors can multiply across the workflow. Agents may call the wrong tool or use outdated context. Costs can increase when many agents run at once. Security risks grow when agents access data and tools. Multi-agent systems need controls, not blind trust. That idea leads directly to human-in-the-loop governance. Because risks can cascade, human review matters. A human can approve high-impact actions. A human can check sensitive decisions. A human can decide whether the agent's recommendation is acceptable. Governance also includes permissions, audit logs, escalation paths, and access control. The goal is not uncontrolled autonomy. The goal is safe, useful, human-guided automation. Once human-in-the-loop governance is clear, evaluation and observability becomes much easier to understand. A multi-agent system should be observable. You should know which agent acted, what tool it used, and why it moved to the next step. Logs help teams debug failures. Evaluation helps measure quality. Monitoring helps detect cost, latency, and safety issues. Without observability, multi-agent workflows become hard to trust. Production systems need more than a good demo. From there, the next practical step is when should you use multi-agent AI? Multi-agent design is useful when the task is complex. Use it when work needs multiple skills. Use it when review or quality checking matters. Use it when parallel work can save time. Use it when tools and data must be coordinated. But do not use it just because it sounds advanced. If one simple prompt works well, a multi-agent system may be unnecessary. This sets up the next important point: simple implementation roadmap. A practical starting point is simple. Pick one workflow that is complex but well understood. Break it into clear steps. Assign one agent role to each step. Define tools, data, handoffs, and review points. Test with real examples. Improve the workflow before scaling it. Improve the workflow before scaling it. That sets up future skills for students and professionals. As multi-agent systems grow, the required skills will change. Students should learn AI basics, prompting, and workflow thinking. Professionals should learn process design and risk review. Developers should learn agent orchestration, tool integration, and observability. Business leaders should learn governance and value measurement. The future skill is not only using AI. It is designing how AI agents work together safely. With future skills for students and professionals in mind, the next piece is final content recap. Multi-agent AI systems use several agents in one coordinated workflow. Each agent can have a specialized role. Agents can communicate, hand off tasks, use tools, and review outputs. This helps with complex tasks in research, support, software, finance, logistics, and education. But more agents also create more risk. Good design needs orchestration, shared context, governance, observability, and human review. The best multi-agent systems combine AI teamwork with human responsibility. To wrap up, here is the key takeaway. You now have a structured overview of multi-agent AI systems explained, how AI agents work together. Review the core ideas, connect them to examples, and revisit concepts like complex tasks need AI teamwork. What you will learn: what is an AI agent? When practicing. Subscribe to Easy Machine Learning Guide if you want to learn AI through simple explanations and real industry examples.